Hello, I'll be presenting how easy is it to run on ppc64le. So this presentation will give you a small introduction and how we, over the past several years, have been migrating workloads to power machines. Initially not open power, but towards the end we reached open power machines. So who am I? I live in Antwerp, Belgium. I'm an IT engineer. We have been a foundation member since 2017. And as some of you may have heard in the introduction, I'm now the TSC chair. I've been involved with Linux for quite a while. Done a lot of stuff for CentOS and RHEL, and now my own PowerEL, which will come later too. So a lot of things around virtualization, containers. I'm also on Twitter, IRC, and wherever. So the introduction. Typically when people start building software, and if you look at most of the people running things, they grab for something that's easy. We build it on the machines we have, which is our laptops. And in that space, x86, typically Intel, has been the king and has been around for quite a long time. And it's easy, it's cheap, it's readily available, so people focus on that. They don't think about other things beyond that, their perspective on that. And that works, of course, when you're studying in university, or that can work well also in different setups, but that might not be what the real world or the business world always uses. And so once we go into that world, you get distributed setups, because the only way to increase x86 boxes is by actually putting more of them together. And so you need to scale out. You get then distributed systems, and then you need to actually manage these distributed systems, and you have vast number of systems trying to coherently work together, and you end up having to build clusters and to manage those. And it might be simpler to have something different in that case. Not to mention only that you need consistency over systems. So it becomes much more complicated if you're looking from a scale out perspective for certain applications. And in that way, we need to rethink what we are doing sometimes and look at different ways of running these workloads. In today's world, where we want to be green and where we want to have the most efficient system possible, it is better to have systems that are measured for their scales and that can actually do what they are meant to do. Then, of course, we had virtualization and containerization more recently, but virtualization meant that in place of doing scale outs, we could actually have on multiple machines run on one bare metal machine. And a lot of rethinking had to be done. A lot of migrations have been done around that. And I think today we can say that most of the applications have been made available for virtual machines in such a way that it is a de facto standard. And so it's very easy to imagine a world where you can just get a virtual machine and it works. And typically those virtual machines, again, run on commodity hardware, which is cheaply and easily available. And in that way, there are different platforms that have come up, and we had to rethink our world. And cross-building had a new meaning. Previously, if you wanted your workload on your something to build, you would build it on your laptop, or you could build it in a build environment if you were luckier. And you could cross-build it for the actual platform you wanted it to run on. With virtualization, we can actually run a full virtual machine on a not on the same hardware, and this enables us to actually build with the native compilers through emulation and virtualization. And so cross-building has a new meaning because it means that we don't need to have everything available at our fingertips. So in our approach, we did what we call the bottom up. We started from the hardware upwards. And then we worked our way up to applications. So we started with acquiring a Power 8 machine in 2014. Power 8 started with a commitment to be open. This is actually the initial setup of the OpenPOWER Foundation, where IBM committed itself to be more open. I don't think many of us from the outside world expected it to be as open as we have it today, or as it will be in the future. But IBM, with the Power 8 introduction, went towards the open world and said that, okay, we want to open up and we will slowly start opening these systems. Primarily, they were looking at Linux. And so a year later, we acquired a Linux machine, or a machine that's specifically built for Linux. And after that, we started looking at how we can get Linux on these type of machines and how we can actually get software running on them. And so we had a lot of discussions with them whereby we realized that the end result would be an open source machine. Like I said, none of us would have thought that it is where we are today. But we started this journey and we took the risk to move forward. However, there were no free open source Linux distributions at that point. No free open source enterprise Linux distributions at that point. CentOS wasn't available on Power yet, at least not for Power 8. And so being in that community, I looked around at what would be possible and what way CentOS was going. Fedora was already available, or was nearly available at that point. Debian has been available for quite a long time. And SUSE was also one of the first ones to be available. From our perspective, initially, we wanted to have full support for ppc64, so the big endian version, and ppc64le, the little endian version. And so we started our journey, and given that CentOS approach was to rebuild RHEL as closely to RHEL as possible, our opinion was different in that, and we wanted to actually get some enterprise Linux distribution on it that would be as close to the hardware and optimize as much of the hardware possibilities as we could. And so we started building our own Linux distribution. In 2015, primarily we started with Big Endian, and then a little bit later, beginning of 2016, we started with Little Endian. We were lucky that we were able to convince a few customers running our e-commerce platform, which is running PHP and MySQL at the backend, to actually allow us to migrate our workloads to Power machines. And in doing so, we also acquired a second machine so we could be highly available, and we could have a setup whereby we could do some testing and some development and QA and workloads, production workloads on these two machines. So we acquired the second machine, and in 2016, we actually migrated our very first customer to an e-commerce platform. From the perspective, it's, as you see, it didn't take us that long. We are not a huge company, so it still requires some effort, and a lot of work has been done to actually rebuild everything. I'll come back to that in a later stage. So what did we actually do? We rebuilt Power EL 7, which was based on CentOS 7, on Power 8 for Big Endian and Little Endian. We optimize, so that means you bootstrap from, in this case, Fedora. You bootstrap from Fedora, you then build your first run on Fedora, you then rebuild whole CentOS with the optimizations the first time, and then you rebuild your own distribution flavor, in this case what we call PowerEL, specifically for Power 8. So it takes 3 iterations to actually get a working package. That not keeping account with the number of patches and the number of tests that we were doing in between there. And then we sat down and we optimized, of course, MariaDB and PHP 5 at the time for Power 8. And so end of 2016, we migrated customers, and in 2017, we had production workloads running on our Power 8 machines, and we were keeping on optimizing these workloads and trying to find new workloads and new customers we could actually migrate to the Power 8 platform. So the customers that we migrated, these 3 that initially started in 2016, are still today running on Power machines. So till now, we have been lucky that none of the customers that we migrated to Power had to ever leave Power again. So for onboarding, we started looking to more workloads. Obviously, we started with the easier setups like Python 3, Ruby, moving to PHP 7, having support for MariaDB, MySQL, Postgres, and Java support. And it's the last one, Java support, that actually got us our first SAP customer. So the customer migrated an SAP workload from non-IBM, from non-Power to an IBM Power machine. And we were looking at what else we could do. And so by starting these 3 bullet pointed versions, so Python, C, Ruby, PHP, we were able to move majority of the web stacks. So any web application you can think of today that runs on these backends typically works very well. And those are the ones we focused on because we knew that we had workloads and customers that could actually do that. Migrating most of the C and the C++ code was also fairly easy. Most of the applications that you couldn't just recompile and you needed to patch was because they presumed that the hardware was running in a specific way. Typically, they were mostly thinking Intel based. So we need to open that up in such a way that it is acceptable for other people to use it and to other architectures to use it. And it was fairly easy communicating with the open source community to getting support for that. There have been multiple previous presentations where they've shown that if we enable these things, it actually migrates quite quickly. And the patchwork typically is fairly limited. And once we patch it, we try to put these patches upstream so we don't need to carry them ourselves all the time. And that makes it easy also. Most of the migrations initially is fairly easy. Once you want to do optimizations, then it becomes a different story and you need to do much more thought process in that. So afterwards, we started being a little bit more aggressive with customers and advising them more to run OpenPOWER machines. We got some customers who migrated from proprietary Power 7 to Power 8 machines. So moving them also to OpenPOWER and Linux machines. Our own machines are mostly IBM machines, but we were able to get some loan machines to test them on non-IBM, so Tian and Supermicro hardware. So we could actually verify that it works on other hardware that is of the same order. Oops. Sorry. And given all that effort, we also became an OpenPOWER Foundation member, given that we were wanting to be more involved in this movement and get more facilities in that area. After that, we were looking at a lot of the AI solutions. So this is around the time when the AC922 came out. And we were successful in helping some of the customers in the automotive industry to implement some of the AI solutions based on that. The optimizations we did there weren't all fully open source because of the nature of the work. However, we tried to contribute as much as possible back. At this point, it became clear that Big Endian would not be a focus anymore in the same way that it has been in the past. And so we enabled and moved our focus to Little Endian. This doesn't mean that we have stopped looking at Big Endian. We still support for Power EL7 Little Endian and Big Endian. For Power EL8, we haven't decided yet. But we started migrating all projects to Little Endian. So the initial setups were typically done on Big Endian, and now we have moved them to Little Endian. So we know that all the workloads work on both Endians. There are a few workloads which only work on Little Endian, and there are a few workloads which only work on Big Endian. And then we started looking at Golang and at porting Golang to Power. And so we assisted with that. And that gave us an entry into all of the container world, because most of the container world software is written in Golang. And so we started looking at open containers. So we have a few customers running Power 9 with AI solutions. And now that Power AI is being open sourced, that's a good thing, and we can have more open source solutions in that. We started looking at open containers, so we skipped all the Docker stuff and moved directly to Podman, which is an open source version. And we've been running containers with Podman already since a year now. Some of them even in production where they are more appropriate. And in 2019, we started being more active in the OpenPOWER Foundation and trying to help communities, open source communities, adopt OpenPOWER, doing more presentations like this, getting people access to machines, helping them out in any way we could, even helping them sometimes with code and with other suggestions. And so now we are looking at what we can do more. From our perspective, we've started building Power EL8, and we will release that soon, which is basically the rebuild of CentOS 8. And at this point, we have a whole bunch of optimizations already in mind, which will help running workloads more efficiently and more streamlined. So what are these optimizations I've been talking about? So to understand what we did, we made a very strict decision in the beginning, and we compile everything with the GCC compiler. And that means that all our compilation is done with open source compilers, and it's done with a compiler that is readily available by the open source community. I know the IBM has an optimized compiler, which does a lot of work, and there have been presentations about that, and those optimizations enable you to automatically get what GCC or LLVM would do. But we chose to use the open source ones, and the ones that are fairly transparent to the outside world, that are also used by all the open source projects that we would like to interact with. And so we started with compiler optimizations. So we went through all of the GCC documentation, figured out which optimizations would work for Power 8 or for Power 9, and we applied those while compiling. So we bootstrap our compiler from a generic. We then include our optimizations. We then recompile everything with our optimized compilers, and we patch wherever needed. All the patches that are not specific to our distribution, we push upstream. Anything specific to our distribution, of course, we don't push upstream. There are a few changes we make, mostly related to naming or copyrights or logos that cannot be used or reused some places. Also, some of the internal changes we make is like, in place of hitting the upstream project, we hit our own mirrors so that we don't create an overload for them in that way. But so all the optimizations that are done there are well thought of and are tested. And it's that work that we actually spend most of the time in the beginning with. And that is one of the things we're also looking at in PowerReal 8, is how these optimizations can further enhance the way we run things. So in our initial Power 8 tests, we were able to run about 15 million queries per second on a MariaDB setup. And we haven't done the tests on Power 9 yet because we don't have a bare metal machine available to do these tests. But in a virtual machine, we are already reaching 10 million transactions per second. And if you would run bare metal, you always get more than that. Most of the newer versions of GCC actually already optimize a lot of the compiler options and will do a lot of the optimizations internally. So we suspect that a lot of the work that we had to do initially will become easier over time. And with a lot of the open source projects looking at OpenPOWER machines and understanding the benefits of them, we will over time again be better off and easier off. So what type of patches are we actually talking about? Most of the patches we have are fairly straightforward and fairly limited. So here you have, for instance, a patch that we had for MariaDB Galera, which is basically, in place of statically putting the multiplier and the page size, what we are doing is we are changing the way the page size and the multipliers work. That is because of the way that Power actually does paging and page sizes. And this is why it makes sometimes a difference in how you apply some of these things. In the meanwhile, MariaDB Galera has already most of these patches in. And so it's fairly easy to do this and to recompile newer versions of MariaDB with Galera in there, with these patches already in there. So it's basically just the paging size, which is architecture specific. Here there are some other changes for build environments. So what we want to do here is not enable SSE for .2 because that's not available on a Power machine. Power machines have different type of optimizations, which is signing, and you see some of the compile options that we add so that we can get the most out of the machine without having to patch the full software entirely. To be able to do this, we need to actually sometimes use extra bits, and so we patch the compilers or the application itself, depending on what is the quickest solution. For about a few years, we have been doing that behind the scenes. So from 2015, more or less, till 2017. And then we slowly started opening up all our infrastructure. And now we actually offer this fully free optimized version. So on the website, you can find all the information, all the patches we have going to our Git system. And as I mentioned a few times, we are looking at PowerEL 8, which is on the way. And we are looking at how we can better support newer architectures or newer type of systems. For the moment, our CI/CD pipeline is because it has a lot of hooks in there, isn't open to the world or open sourced on its own. So I'm looking at how we can do that in the future and how we can open that up. Okay, so these are some of the applications that we were able to migrate. I can't put all the names there because of sometimes NDAs with our customers, but these are the ones we can talk about. These are the open source ones. There are a lot of web apps which we have also migrated and are able to run on Power, and which are fairly easy to migrate yourself. So, and then yes, if you have any other workloads you can think of, how can we empower you to get them on Power? Thank you for your attention. If you have any questions, you can ask them in Slack. I see there are a few come in. If you have any questions afterwards, you can always email me. So, which version of GCC do you use? So for that, we decided to go with the version that comes from the upstream distribution we are using, in this case CentOS. So for PowerEL 7, that's 4.8.5, with a lot of patches in there, so that we can actually compile a lot of the newer software in there, but it's more backporting than anything else. And for PowerEL 8, if I remember the version well by heart, that's 8.5 or 8.6. That one isn't out yet, so once that comes out, we'll be using that. Did we consider to use the IBM Advanced Toolchain? Yes, we did. Yes, it has a newer version of GCC, and it is compiled and optimized with a lot of optimizations in there. The reason why we decided not to go with that was to be as transparent for the open source world as possible, and also to have the ability to run CentOS binaries or RHEL binaries on PowerEL, which means that if you today have any binary that was compiled for CentOS or RHEL, they will automatically work also on PowerEL. And we, in our initial test, we were not able to guarantee that if we use the IBM toolchain. Do we make use of SSE compatibility implementations on Power in recent versions of GCC? So for PowerEL 8, yes, we will be using those newer versions, and we will actually be looking at how we can get vector intrinsic optimizations in there. And we are actually, that's one of the reasons why we haven't released PowerEL 8, is because we want to drive those optimizations further and be able to use those much better than what we did in the past. And I think I'm out of time. Those are the questions that I'm able to do in the session itself. If you have any other questions, I'm also on Slack or email me. Thank you.